Hello everyone, welcome to TG Campus. So now we have a very important chapter, limit. This is a part of calculus, and this is not just a part. Basically, this is a very important part of the calculus because you can prove every differentiation or you can derive every function with the help of the limit, and you can even though you can derive the integration with the help of the limit. So we can say that yes, limit is a very important part of the calculus. Okay, and for functions, basically this is the part where we used to check functions exist or not. So this is a really important part of the chapter and we have to focus on that. Okay, so let's start this limit. So guys, the first thing in the limit is concept. What is the concept of limit, and what is basically actually is limit we are talking about, and why we have to use this limit, and what are the basically benefits we have from this limit. First of all, we'll discuss the concept. What is concept of the limit? Limit basically used for checking the function exists or not. We have more work for the limit, but right now the basic concept of limit is, let f of x be a function defined at all values in an open interval. Hope you are aware with the open interval part. When we talk about the open brackets, you can say that open interval containing a with the possible exception of a little, and let L be the real numbers of all values of the function f of x approaches the real number. It means if I have some function f of x in some open interval, like I can say that but within a and b, okay, between 2 points, open interval. So if my f of x approaches to some point between a and b, we can say c or any other point, if it is approaches to that particular point, so okay, so what will happen is the real number as the value x, where x is not equal to a, approaches the number a, x is approaching to a number a, then we can say that the limit of f of x as the x approaches a is L. Limit of my function when x approaches a is L. Okay, I'll tell you in a very simple way only. See here in this on the number line. So we have this number. I'll draw a number line here. This is 0. Here I have some negative a, and this is some positive value, x is equal to a value here. Okay, and this number line we can say that is going till infinity, minus infinity to positive infinity. Okay, so this at this function at this particular point, my function, I'm talking about the existence of this function f of x at particular point a, x is equal to a, but I'm not taking x is equal to a, I'm just approaching this value. I will try to approach this value from both the ways, from left hand side and the right hand side. I will approach from here. Well, that's why I've written here as limit x tends to a. X tends to a means it is approaching to a, it is not equal to a, it is reaching at that point. So from both the side, so if I'll say from this and from this side, it is approaching to the a. Okay, so in that case, when it is approaching from both the sides and we are getting the same limits for those things, so my function will say that the limit when x approaches a, my function will gonna give you some real number. Okay, we can say some finite value. Okay, when x is approaching a, we are going to get some finite. I'm not saying at x is equal to a, but when x is approaching a, we are going to get some finite value. Okay, so this is a concept limit. Basically, when a particularly real number x is approaching some value, so my function will approach to some value, some real number. Okay, so okay, probably you are thinking that why, okay, what, even though is it approaching to x is equal to a and my function is approaching to L, but what is the advantage of that, or what is the benefit of that? Basically, how to check my function exists at particular point x is equal to a means we will not stop at this point, so it will be from this both the side, from left hand side and right hand side. So for that we have a limit. Basically we can say left hand limit and right hand limit. So that's what concept limit says, that when both the side limits are equal at for a particular point x is equal to a, in that case we can say that my function exists at that particularly value x is equal to a. Okay, so this is the concept limit says that. Okay, so what is the point? Again, I'm telling you, at this point, if I want to check my function exists or not, it means from if I'll approach my function x is equal to a from both the points, it should be same.